My name is Wes Olson. I'm a retired Canadian National Park warden. I spent 32 years working for Parks Canada, most of that time involved in bison management, uh, mostly in Elk Island, but also in Grasslands National Park, and occasional stints in the mountain parks as well. The whole topic of bison physiology and anatomy begins with their grazing behavior on the landscape. As bison forage through the grasses, their noses are constantly embedded in the vegetation that they're eating, in the grasses and the forbs that surround their nostrils. And those plants are laden with microbes, bacteria, protozoa, and fungi that live on those plants. Every time the bison inhales, he's inhaling all those microbes with that breath of air. And they get stuck in the nasal vestibules, just inside his nostrils. So if you watch a bison foraging across the landscape, you'll see him periodically lift his head and then give a quick clean out of both nostrils with his tongue. He's doing that to partially clean that mucus of the accumulated gunk that he's just breathed in. But it's more important than that. Every time he cleans his nostrils, he's ingesting, swallowing all the microbes that he's picked up. And they're critical for his survival. Without those microbes, no ungulate on the landscape, no cloven-hoofed animal like an elk or a bison or a moose can digest the rough forages that they're eating. They need those microbes to digest the vegetation. So when he cleans his nostrils, he swallows all those microbes, and they first enter his rumen. That's the first stomach of a bison. They have 4 stomachs. And the rumen it's the equivalent to a compost bin that you put compost in and then you turn it. It's a fermentation vat. They ingest great quantities of grasses. It all goes into the rumen where it sits, and it's a stratified layer of the oldest forage through to the brand new stuff. And it's constantly churning and mixing, and they'll swallow a mouthful, it'll sit there. And then once he's had time to finish his meal, they'll go off and lay down and chew their cud. And in doing that, they burp back up the foods that they've just eaten, chew it a bit more, and mix it with enzymes that are in their saliva. It goes back into there and then eventually through the digestive system and out onto the landscape when they deposit their buffalo chips. Well, it turns out that the microbes that they're eating contribute up to a quarter of the protein that they need to survive on the Great Plains. And they break down the fibrous vegetation into a form that can be digested. Not all of it is digested, so some of those microbes and bacteria and fungi end up being deposited in a buffalo patty on the landscape. And that's important for the whole ecosystem because those buffalo patties are a complete ecosystem all on their own. The microbes that have gone into the dung then feed a whole host of insects that arrive within seconds sometimes. And dung beetles in particular are one of the first to arrive. They don't actually eat dung, as their name would imply. They eat the microbes and bacteria that are living within that fresh dung pad. They're the equivalent of a blue whale swimming through the ocean eating krill. So they'll completely destroy that patty in a matter of just a few days sometimes. All of that nutrition is then circulated across the top of the soil and down into the roots, depending upon the species of insects that are foraging there. And then of course that fertilizes the grasses that another bison will eat somewhere down the road. Bison are superbly adapted to life on the open plains, and particularly the plains bison. They're an animal that has a body hump, or body shape where the highest point of the hump is centered over the front legs, and it's a rounded top to the hump. And as they move, that hump rotates over the front legs, and it gives them what's known as a cursorial gait. It's a moving system that is very energetically efficient, allows them to cover vast distances, but not a lot of energy expenditure. And because the hump is centered over the front legs, it also acts as a pivot point where they can spin to fight other rival males during the breeding season or to defend themselves from attacking predators. So the physiology and anatomy of plains bison is, well, it's taken thousands of years to adapt to life on the Great Plains. One of the things they're not great at is traveling through deep snow. There's been work showing that if the snow depth gets deep enough to exceed 2/3 of the height of the chest, so from the underside of the chest to the ground, that's the point where they can't eat enough to accommodate the energy they're expending getting through the snow. And on an average plains bison bull, that's 44 centimeters of snow is the depth at which it becomes energetically limiting for an adult bull. Of course, it's much lower for calves or for smaller animals. And that's one of the reasons that when you see a bison herd moving across an open landscape in deep snow, they do it in single file. It's usually a lead cow that's breaking trail, and then everybody else follows in behind. So another adaptation to life on the open plains. Plains bison, as I mentioned, are a species that evolved on the open Great Plains, and all of their physical skeletal structures are designed to adapt to that landscape. One of the things that is different between a plains and a wood bison is the placement of the highest point of the hump. On a plains bison, it's centered right over top of the front legs. On a wood bison, if this is the highest point of the hump, it's well forward of the front legs. And if you look inside the structure of that hump, the spine comes across at about this level, and then there's these long neural spines that travel across the top of the vertebrae. On a plains bison, they're centered sort of like that. They get shorter towards the head and shorter towards the hip. On a wood bison, it's up here, so that the highest point of the hump is suspended quite a lot higher. And those neural spines of the vertebrae are like a suspension bridge. They've got a ligament that travels across the top. It's called the nuchal ligament. You and I have one that travels up our spine. And it acts as an elastic band that allows the vertebrae to expand and contract. On a plains bison, the hump it ends right at the base of the skull. On a wood bison, the head is suspended out quite a bit from the hump. And those are both adaptations to the environments that they live in. Plains bison, because they live in environments with relatively shallow snow most of the year, depending upon where they're at. They forage through the snow using their foreheads and their noses to push the snow side to side. They don't use their feet like a horse or an elk would to get at the vegetation. So they don't need a long neck to penetrate deep into the snow. Wood bison, on the other hand, live in a northern boreal forest environment where the snow can exceed a meter routinely. So they need to have a structure that's designed to support that head for 8 months of the year foraging through snow. So the structure of the skeleton, especially the humped part of the skeleton, is different. One of the adaptations that plains bison have to life on the open plains is their hair coat. If you look at an adult male plains bison in its summer pelage, there's a sharply demarcated cape line right behind his shoulders. Ahead of the shoulder towards the head, it's all a dense mat of hair, but from the shoulders to the hips, it's essentially hairless. That hairless area is called a thermal window. It allows the excess body heat from hot summer days to be radiated out into the environment. On a wood bison, the hair grades smoothly all the way back to the hips, and they're not in that hot environment, so they don't need as much of a thermal window, but they do need protection from biting insects. They can be horrendous in the north. So completely different hair coats on the body of the bison. And then if you look from the underside of the body towards the ground, on a plains bison, all of the hair coat characteristics make him look bigger in profile. It's the breeding plumage, equivalent to a breeding bird, songbirds, for example. So the shafts that hang off the back of the front legs, the neck mane that comes from the front legs forward towards the chin, the big beard on a plains bison, all of those are designed to make him look bigger in profile. First as a way to intimidate rival males, and say, well, I'm bigger than you, don't even bother with me. And if that fails, then it proceeds into a breeding combat. On a wood bison, they lived in an environment with tall sedges and low shrubs, and there was no no evolutionary advantage to expending the energy to develop those big hair coat patterns. So they're virtually non-existent on a wood bison. Their front legs look more like a cattle front leg, short hair. And they have a thin, pointy beard and a very thin ventral neck mane. On a wood bison, the hair between the horns falls forward like almost in horse-like bangs, whereas on a plains bison it completely fills that space in a big bonnet. Again, adaptations to make them fit their environment better. In addition to the adaptations that bison have to hot environments, and they lived in places like Texas where the routine daily temperatures will exceed 100 degrees Fahrenheit, but they also live in cold environments like here in Canada where ambient temperatures can drop into the minus 40s. So they also have adaptations to extreme cold. And in their legs, for example, they've got a good hair coat on their legs, and a little bit of fat just underneath the skin, but the tissue can freeze. So a way a lot of northern mammals have adapted to cold environments is with a circulation system that's called a countercurrent circulation. And that's where the warm blood from the heart travels down to the extremities, and the cold blood from the extremities travels back to the heart. But those veins and arteries are side by side, so that the warm blood heats up the cold blood, and the animal's extremities stay warm. It's how birds with their tiny little wee legs can survive in frigid temperatures. So countercurrent circulation is a tremendous adaptation to cold environments, just because of the way the blood circulates in the extremities. So if you're traveling through a national park or a place where there's free-roaming wild bison, or even on bison farms and ranches, in the summer months, you'll see that the bison are in large herds. And that's an adaptation, again, to the breeding season. And early explorers passing through the Great Plains remarked about being within one buffalo herd for 10, 15 days at a time, just a continuous sea of bison. Those are always midsummer rutting aggregations, when multiple hundreds of herds would coalesce together into one massive summer breeding population. And they're designed to bring everybody together in one place at one time, so that the bulls can compete against each other for the right to breed the females. And the females play a significant role in deciding which bulls get to provide that. It's a place where all members of bison society can learn how to be members of a bison society. And they have a very structured social dynamic. Newborn calves are big enough from July to August. The peak of the breeding season is roughly August 1st. It changes as you move north or south in latitude, but roughly centered on August 1st. So the calves that are coming into that population at that time are a month to 2 months of age, and it's that point where they're beginning to learn how to interact with their peers and with animals that are older, and to establish their place in the social hierarchy. When the breeding season comes along, the bulls have dispersed even further from the main cow herd. They'll go and look for isolated small patches, and there might be one bull there or two or three, but they don't form large groups. When a male grows up in a mixed herd of cows and calves and yearlings, and the whole demographic is sort of structured, he looks like a female until he's 3 years of age. It's an adaptation to predators again. He blends in with the cows and they can't pick him out. But during the summer of his 3rd year, his hair coat changes and he looks like a male. They get that deep, sharply demarcated cape line, and he now has a choice of staying with the cow-calf herd. He's still an immature animal. He still likes being around mom. But it's dangerous because now he looks different. So at the end of the breeding season, all the males will disperse and be separate from the cow-calf herd right from the end of the breeding season through to the following one. And they scatter off across the prairie in small groups, coalesce again during the breeding season. And those young males will move up through the social totem pole, practicing on their equals, other bulls of a similar age, until they reach about 7 or 8 years of age. And that's the point where the hormones really kick in and they begin to assert themselves or try to assert themselves as breeding bulls. The classic breeding bull is between 8 and roughly 12 years of age. Those are the ones that do the bulk of the breeding. And depending upon where they fit within the social dynamic, those are the bulls that you'll see the dramatic footage of them battling head-to-head fights. And they're one of the few species that actively tries to kill each other during the breeding season. The goal is to get their heads together and then hook and try to rip or get. So those are life-to-death battles. Probably 2 to 3% of breeding age males will die each year from rutting-related injuries. So those young bulls, they have to practice and figure out how they fit into the system, and then move up through those social ranking. As they approach those dominant bulls, they'll spar with them, but quickly be defeated either just by the broadside displays and behavioral displays, but as they age, then suddenly it becomes more serious. and the battles begin. They'll do that until they're about 15 years of age, and then they might come and associate with a cow herd during the breeding season, but it would be just a brief foray in and then back out again. Or they might not come at all and just spend the rest of their lives out segregated from the herd and not interested in participating in the rut anymore. Once the grasses begin to cure towards mid-August, those big rutting aggregations can't stay in one place very long because the grasses are beginning to decline in nutritional quality. So the herds break up. The typical breeding season takes about a month to 6 weeks from end to end. And by the time the breeding season's finishing, the grasses are curing and the bison herds disperse. And they'll break up into much smaller herds. Historically, a smaller herd would be thousands of animals. Today, in most sanctuaries, it'll be anywhere from 50 to 100 or less. And they'll break up into smaller groups scattered across the landscape, each of those groups led by a dominant breeding age cow, usually an older cow, and often one that doesn't have a calf. She's the equivalent to an elephant matriarch that leads the herd. Those groups then disperse across the landscape seeking out higher nutritional quality vegetation or places that haven't yet been grazed, so they've got a higher biomass of food. And they do that right through into the approach of winter. And depending upon what part of the North American Great Plains they're on, they use different dispersal strategies. In the southern plains of Saskatchewan, northern Montana, where there are no trees, it's just vast open windswept native prairie, they'll move up onto the high ridges in hilly country because those are scoured clean of snow. And that's the place where they can access the food the easiest. Coincidentally, on the Great Plains, that's also where native people would seek out their winter encampment sites. Places like Grasslands National Park, all of those windswept ridges are where you'll find teepee encampments, the teepee rings that they left behind. As you get more north or towards the mountains, bison will disperse into areas that typically are fairly damp through the summer, places where there's sedges that are growing. Sedges have the advantage, several advantages for bison. Because they're a very stiff-stemmed plant, they hold the snow off the ground in a soft loft. It doesn't compress like it does on the open plains. So bison are able to move that snow easier than they could on a windswept snowpack. And sedges have the advantage, because the snow is deep and soft, they can produce fresh new shoots of green vegetation right through the winter months in that 1 or 2 inches below or just above the soil interface. So bison move in there, and there's lots of records of people saying bison migrated from the plains to the forests for shelter. I don't think it was for shelter. I think it was access to that specific type of winter food that they needed. And then come spring, after everybody's survived, cows are in lean body condition, probably not a lot of body fat left. So they're seeking out areas that will green up first. It's referred to as following the green wave. As green up happens from north to south across the Great Plains, there would be a seasonal migration northwards for some of the southern populations. And they're following that fresh green growth that's erupting on the landscape as the snow melts and spring arrives. Those spring cows, because they had very little body fat, were the ones that native people harvested every spring to create new covers for their teepees. They were the thinnest leather, so it was the easiest to tan. They were slipping their winter hair coat, they were shedding it, so getting the hair off was easier. There was less fat to cleanse and to clean off. So every year there'd be a large-scale hunt to replenish teepee covers, but just of those spring cow hides. Every other hide was not suitable for teepee liners. So the cows then will disperse into their traditional calving areas, and that varies again depending upon the part of the landscape they're on. But they try to typically go back to places that they know they can calve in security, places that are secluded perhaps. And then they go into a process called a synchronized calving season, where large numbers of pregnant cows produce large numbers of identical looking calves in a very short period of time. And that's an adaptation to an anti-predator adaptation. It's like walking into a candy store with 1,000 choices. You can be in there for a day before you make up your mind. But if you've only got one choice or two or three, it's easy. Oh, I want that one. It's exactly the same for wolves. If suddenly they're faced with vast numbers of identical looking calves that are moving and shifting, it's difficult for a predator to focus and say, I want that one. But if there's only a few, it's easier for them. So they have this synchronized calving that ties back to the previous summer when they had a synchronized breeding season. The calving gestation for plains bison cows is just longer than it is for people, maybe a week longer. So from breeding season to calving, it's a very concise, scheduled event on the landscape. Then they become aged bulls, and those big old aged bulls they're the monsters in the herd. They stand out distinct from everybody else because they're so big. The average adult male plains bison, when they're fully dominant, probably weighs around 1,000 kilograms, and then they begin to decline as agedness begins to kick in. The average plains bison cow will live to and be productive into her early 20s. I know of 2 records of cows that were 40 years of age. One of them died giving birth to her calf. But the average bull only lives to be late teens to early 20s, just because of the stresses that they're under. During the breeding season, the dominant breeding bulls will lose up to 1/3 of their body mass just because they stop eating. They're so busy defending their cows from the approach of other males or fighting other males that they lose a tremendous amount of weight. And then if they don't regain that weight through the winter months, many of them will succumb to weight loss. So as these old males reach maturity and old age and then begin to die from either injuries or the trauma of participating in a breeding season, and they'll die on the landscape. Historically, there were tens of thousands probably of dead bison naturally on the landscape every spring, either died through the winter or killed by predators or by people. And those carcasses played a hugely important role in ecosystem diversity and health, because that flush of 1,000 kilograms of meat onto the landscape fed a whole host of other species, literally tens of thousands of insects. And then the insectivores that came along and ate those insects. They can be migrating birds or resident birds, amphibians, reptiles, and then all the way up through the food chain, the scavengers that would come in, wolves, grizzly bears. One carcass could sustain a huge population of other species. And when you have thousands of them on the landscape, the diversity and complexity of that ecosystem would have been astounding. That all changed, of course, with the decimation of bison across the Great Plains. Within a matter of a few years, all of that biomass disappeared, and so too did all the species that depended on bison, either as a prey base or scavengers, insects. The insect that lived on the bison dung disappeared as the dung disappeared. So it had a huge impact, the decimation of bison across the Great Plains. And of course, it wasn't just the adult bulls that were dying. Cows often died as well from predation or for a variety of causes. If it was a really mild winter and they were able to maintain or even put on body fat during the course of the winter, that actually worked against them. Bison cows need to enter the calving season in lean body condition, because that calf has to pass through the birth canal. And if that birth canal is plugged up with excess body fat, occasionally those calves would die, either in the cow, in which case she would also die, or the cow would die after the calf was born. And sometimes even a week or 2 after the calf was on the ground, the cow might have had an infection that then led to her death later, leaving that newborn calf on the landscape. Some cows will adopt and nurse an abandoned calf or a calf whose mother has died, but it's unusual. Very likely most of the abandoned calves or orphaned calves would be susceptible to predators historically, and very few of them would have survived. So I touched on bison's social structure a bit in relation to the breeding season and the dispersal of males from the group. Bison have a very structured social dynamic. As those young animals move up through the social totem pole, initially the calves inherit their mother's societal ranking. Dominant cows will produce dominant calves, and especially if it's a female calf. That female calf will inherit her mother's dominance. And that'll work to her benefit, because then she can benefit from forage resources or from going to a pond for a drink. If you watch a herd of bison moving across the landscape and going towards a water source, it's always led by a dominant cow with her dominant calf at her side. And she'll go down and have a drink. It might be there for a few minutes. Everybody else follows her to the water hole. But the ones who are straggling behind, usually subordinate animals, might not have a chance to drink, because the dominant ones will get their fill of water and then they leave. And then the subordinate ones, the ones at the back of the herd, have a choice. Do I stay and get my drink, now within a much smaller group of bison, and present myself to the risk of predation? Or do I just say, well, I'll get a drink another time and follow the herd back and keep up with the security supplied by a larger group? So often the subordinate animals will not be able to obtain the liquid that they need to survive out there. And they can decline in body condition as well. So the structure of the group, the number of dominant individuals and subordinate individuals, plays a role in how they all survive on the Great Plains. Typically in the summer months, it's a complete mix. The whole demography is present, from calves through to the aged animals. Then it breaks down as the bulls leave the group later in the summer months. Bison, of course, had natural predators, and on the Great Plains that was the prairie wolf, the gray wolf. They were constant predators of a bison herd, circling the periphery of it. And literally tens of thousands of them were slaughtered during the same period that bison were slaughtered on the Great Plains. Grizzlies, of course, extended right out onto the middle of the plains. They were one of the most numerous predators that people like the Lewis and Clark expeditions would encounter. Often 20 to 30 grizzlies in a single day that they would see. There certainly were mountain lions or cougars on the landscape, but they're not effective predators on bison. Cougars their primary method of attack is to bite the nape of the neck, or to smother the nostrils of their prey. And they can't do that very efficiently on a bison. I think they could take young animals, but at an insignificant rate. And those were the primary predators. Then of course came the scavengers, the red fox, the swift fox, the kit fox, and coyotes that would travel around the periphery cleaning up carcasses, but more likely foraging on the mice and voles that are disturbed by passing feet and grazing heads of the bison. You can routinely see them hunting in and around bison herds, picking up those small mammals. Bison, of course, were also susceptible to diseases. And one of the diseases that played a significant role in the decline of plains bison at the same time that they were being extirpated through overhunting was Texas tick fever. There was a tick that lived in Texas and transmitted disease to the bison that killed thousands of them. There's one report of a summer prairie looking like a pumpkin field with all these dead bison carcasses, likely from Texas tick fever. And as our bison were extirpated from the south to the north across the Great Plains. They were followed within a very short period of time by huge herds of Texas longhorns that were driven up the Chisholm Trail, for example, all the way up into southern Canada, into southern Alberta and Saskatchewan. At the same time as the bison populations were being decimated, settlers were moving in from the east, bringing their cattle with them and setting up their farms and ranches. And as they were moving east or west into the Great Plains, the big Texas cattle drives were moving north, bringing Texas tick fever with it and affecting the settlers' cattle herds. So there was a major outcry that you can't bring your Texas longhorns through my property. So there'd be a shift in the location of the cattle drives. And eventually, of course, the bison were gone and the landscape was populated with cattle. And cattle can spread historically. When TB and brucellosis were rampant in the North American cattle populations in the 1800s and early 1900s, they could spread those diseases to bison because bison are susceptible to cattle diseases and all of the parasites that cattle carried with them. Parasitism is a natural thing in bison. They've always had internal and external parasites, but not to the point that they were detrimental to their welfare, unless they were stressed by a bad winter or something that could push them over the edge. And it wasn't just heat or cold that caused the death of bison. It could also be extreme drought, for example, or extreme severe winters. There were several really nasty winters in the mid to late 1800s, two in particular that wiped out literally hundreds of thousands of cattle across the Great Plains, but also in the north killed thousands of bison. And wood bison in particular suffered massive losses in the 1890s from severe blizzards that would pound them relentlessly for days on end, or it would lay down be a warm period that would create an ice crust and then snow and then another ice crust that made it impenetrable to get through for them. So severe winters would cause massive mortalities across the Great Plains and right up into the boreal forest. And drought was another significant one, especially across the southern plains. Long extended periods, sometimes a decade long, would completely devastate the prairies and bison starved to death by the tens of thousands probably. So adverse environmental conditions can certainly play a role in the ability of a bison or even a bison population to survive. And with global warming, the way it's moving now, there's research being done in the US looking at the ability of modern bison to survive climate change. And if you look back at the geologic scale of bison in North America, the current plains bison are the smallest of all of the species that ever lived on the continent. And that's an adaptation to changing temperatures in particular. There's in ecology a rule referred to as Bergmann's rule. Bergmann was a German scientist who discovered that as you moved from the equator north, all mammals got bigger. Doesn't matter whether you're a mouse or a human. And there's a ratio between the surface area of the animal and its ability to retain heat. So as you go north, body mass gets bigger to give those animals a survival advantage. And as temperature increases with global climate change, that's going to contribute to make animals smaller. And you can demonstrate that now in North America with plains bison in Texas being smaller than plains bison in Canada. So as climate changes over the next decades, there could be a continued shrinking of bison size over time.